Question 1 here gives us an f of x equation and wants us to take the derivative of it. So when we look at any equation, the first thing that we want to know is that we can break it up into bite-sized chunks by pluses and minuses. So really we have this 5 plus x cubed squared as its own derivative, minus, and then the second piece here, 3 plus x squared to the fourth is its own derivative. So as I look at these pieces, both of these pieces fit the form of a chain rule problem. And so my chain rule saying is d in, d out. So whenever I've got something inside of something, I follow the rule d in, the derivative of the inside piece, times the derivative of the outside piece. So if I take these in bite-sized chunks and just look at that first piece here to begin with, and I look at my 5 plus x cubed squared, the 5 plus x cubed, that's what I would consider to be the inside piece, and so I'll look at that piece as its own chunk. And then the outside piece is really that squared power, so it's a bunch of stuff to the second power. So taking these pieces and finding my d in, the derivative of the inside, the derivative of 5, a constant, just goes away, and then the x cubed, the 3 comes down, and then we subtract 1 from the power, so we get 3x squared. On the d out on this is really just a big power rule. I'm bringing that 2 down in front. I would leave all the stuff alone on the inside and then subtract 1 from the power. So that'll be that chunk. And then we can go ahead and do the same thing with our 3 plus x squared to the fourth right now, where our inside piece in this situation would be the 3 plus x squared, and our outside piece would be a bunch of stuff to the fourth power. So our d in, the 3 again is a constant, so it would go away. And then we do a power rule on that x squared, bringing the 2 down, x, and then subtracting 1 from the power would leave us with just a single power on that x. Doing our derivative of the outside here, again, this is just a big power rule. You're bringing that 4 down in front, leaving alone all the stuff on the inside, and then subtracting 1 from the power. So now we've broken down our problem, and now we can go ahead and bring all those pieces back together to get our final answer for our derivative, our f prime of x. So looking at the first piece, this was a chain rule. We needed to do a d in, d out on this. So the derivative of the inside times the derivative of the outside. So the d in was the 3x squared piece. The d out is this 2, and then again I leave everything alone that I already took the derivative of and subtract 1 from the power. Then I've got a minus sign in the middle here, so minus, and then I'm going to do another d in, d out on my second piece here. So my d in on this would be 2x. My d out would be bring the 4 down, leave all the junk alone you already took the derivative of, and then subtract 1 from the power. So there's our final answer, and so I come up to my options up above, and I can really kind of throw out A and throw out B just visually looking at them. And so looking between C and D right now, I can see that I've got up in the front here, I have a 3x squared, so there's a 3x squared, I need a 2, and I've got a 2, and then 5 plus x cubed. And you'll notice that D here is missing that 3x squared. That's not what we want. So answer C would be the right answer. And you could go through the rest of the pieces to make sure. The one thing to be careful of on something like this is the sign in the middle here can change if one of your pieces, say, has a negative sign on it. So make sure you get the right sign in the middle. That's always how they trip people up on these, is you get 95% of it and then miss one little sign, and that changes the entire answer.